All right, hey guys, this is my second attempt at recording the second half of 4.1 because it didn't work in class. So starting with example 6, I think is where we left off at. And the second half of this doesn't take very long to go through, so hopefully this isn't too long of a video. But example 6 starts with texting and driving, and it says that in a study of U.S. high school drivers, it was found that 3785 texted. So I'm going to put T equals 3785. And then during the previous 30 days, and then did not text, so I'm going to put NT for 4720. And then I'm going to go ahead and total that up because I'm guessing that we're going to need that number. 37,785 plus 4720, and that total is 8505. Okay. Based on these results, if a high school driver is randomly selected, find the probability that he or she texted while driving. Okay, sometimes they'll use the notation like P, and I'm going to put P of text, and that's just saying the probability of getting a texter. Okay, probability of text is 3785 out of that total, 8505, and we convert that to a decimal, and we get an answer. So 3785 divided by 8505, and we get 0.445. So just one thing that I will caution you on is that I want you to make sure that you read on your homework assignment whether they want it as a decimal, rounded to 3 decimal places, 4 decimal places. Sometimes they'll want it as a decimals or as a percent, so you do 44.5%. So just depending on what they want, read the fine print below, and they'll say what they want the answer to be formatted in. Okay. Example 7 is kind of a trick question. They say if a year is selected at random, find the probability that Thanksgiving Day is A, on a Wednesday. So we want the probability of Wednesday, versus B, they want the probability of it being on a Thursday. And don't try to do this problem yet. Like Wednesday would be like 1 out of 7, or Thursday is 1 out of 7. No. Think about actually Thanksgiving Day. Thanksgiving Day is always on a Thursday. So that means it has a 0 probability or a 0% probability of being on a Wednesday. It has a 1 or a 100% probability of being on a Thursday. Okay, so this is the probability as a decimal, this is the probability as a percent. Okay, but they're just trying to bring to your attention in this example that you can have a probability of being 0 or 1, and that's kind of the case with this one. Okay, going to the next page, we have something called complementary events. Okay, so I want to talk to you about let's talk about what P of A looks like. This is the probability of event A happening. Okay, and that would be the probability of getting a heart. Okay, if you're drawing a card, there are 13 hearts out of 52, which reduces, so you have a 1 in 4 chance of getting a heart. But then if we're trying to do the complement of that, the complement of that is represented as a bar. They'll always put a bar over top of it. So that's the probability of not getting A to happen. Okay, so that would be probability of heart bar in this case would be the probability of not getting a heart. Okay, and there are, let's see, 39 cards that are not hearts out of 52 then, which would be 3/4. So we have a 3 in 4 chance of not getting a heart if we have a 1 in 4 chance of getting a heart. Okay, and one thing that you will notice is that these two, the complements of each other, always add up to be 100% or 1 as a decimal. Okay, so that's just kind of how that works. All right, so they're going to have us do the complement in this section. They say the complement of the death from skydiving. So in example 3, we did that there was 21, so the probability of death or dying was 21 out of 3 million when we did example 3, which we came out to be 0.000007. Okay, that's the probability of dying, but we want the probability of not dying, which is the complement of that. and we would subtract that from 1, and that would be 0.999993. Okay, so the complement, those two are just going to add up to be 1. So you could take 1 minus 0.00007 and get that answer. Okay, relationship between PA and PA bar is that they add up to be 1, so they equal 1. Or 100% if you have it as a percentage, okay? Significantly high and significantly low, we've talked about that before, where it's considered significantly high and significantly low if the z-value is less than -2 or the z-value is greater than 2. But as far as probability go, if it is considered significantly high or significantly low if it has a less than 5% chance of happening randomly, okay? So like there's a less than 5% chance that something lives over here, and there's a less than 5% chance that something lives over here. So probabilities being less than 5% will tell you whether it's significantly high or significantly low, okay? So like the example that we did, at the very beginning of this section up here where we talked about boys versus girls, and the 75-25 split versus the 55-45 split, they said that they crunched the numbers, and the chances of getting a 75-25 split just by chance, by randomness, was 0.000003, which is less than 5% or 0.05. So this, we can conclude, is significantly low, or is significant. I'm just going to say is significant, because the chances of that happening just randomly was that. So we can conclude that, yes, that's a significant number of girls, so whatever supplement or whatever thing that I'm making the mother take before they conceive the child is being effective in producing girls, okay? Versus this one, if we get a 55-45 split, yeah, it's giving us more girls, but the chance of that happening just without a medication would be 18%, which is greater than 0.5. So this is not a significantly high number of girls. Therefore, my medication is not really doing anything significant. Okay, so that's kind of how that breaks down. It has to be less than 5% chance of happening randomly in order to be a significant number. All right, probability review. Let's go through these just really quick. Probability is always a number between 0 and 1. So you can't have negative numbers. You can't have numbers greater than 1. You can't have fractions that are larger than 1. Like we would not have like 4/3 or something like that, right? Because that's a number that's bigger than 1. The probability that is impossible means that the probability is 0. If it's certain to happen, then the probability is 1. The notation PA is the probability of event A. PA bar is the probability that event A does not occur. Okay, so that's just kind of going through that stuff. Now let's talk on the back side. This is the last thing that we have, which is odds. And odds is kind of a little bit of a different beast than what probability is. And odds are used a lot when they're talking about like sporting events, or like on ESPN, they'll talk about like the odds of somebody winning, okay? And a lot, like 99% of the time, the way that the ESPN and the people on TV use the word odds is incorrect, because what they're referring to is probability, and they're using odds to be the same as probability, and odds is different than probability. I'm going to show you what the difference between is. Okay, so when we're calculating probability, it's what we want versus what we do, versus the total. Okay, so like the probability of getting a heart we just did was 1/4. Okay, versus odds is what we want in comparison, and instead of doing as a fraction, we do a colon. So it's want versus don't want. Okay, so if I have a 1 in 4 chance of getting a heart, the odds for hearts, let me do odds. I'll do an arrow. The odds, so the probability is saying that there's 1 card in every 4 that is a heart. Okay, so for odds, I would have a 1 card that's a heart versus every 3 cards that's not a heart. So this would be the odds of drawing a heart versus the probability. Okay, so it's just a little bit different. These two numbers here for odds should always end up adding together to be that bottom number for probability because that's the total, okay? So odds versus probability, 99% of the time they're using the word odds to represent probability when they're talking about sporting teams play, okay? So it's usually used incorrectly. Odds make it easier to deal with money transfers, so when they're dealing with casinos and lotteries and racetracks, they'll a lot of times say like a 1 to 3 odds or a 2 to 5 odds, or whatever. Probabilities make calculations easier, so probability is used a lot by mathematicians, scientists, researchers, statisticians, all of that good stuff. Okay, now odds isn't always what we want versus what we don't want, because if you have odds against something happening, odds against would be don't want versus want, and then odds in favor would be want versus don't want. Okay. So they might switch that around. If they say odds against, you're just flipping those around. So there's how that works, okay? And then we'll talk about payoff odds here in just a second, okay? So here's the deal. Here's our example. You're going to have a homework problem that's very, very similar to this, and they even have like the ABC set up pretty similar, okay? So if you bet $5 on the number 13 in roulette, I had to look this up. A roulette wheel, you spin it, and it has 38 different slots on it, and 13 is just one of those numbers. So you have a 1 in 38 probability of winning, right? Okay, but this is how the casino sets it up. They are setting it up so you have a 35 to 1 payoff. This is how much you pay off, okay? All right, so we're going to talk about that. So don't worry about the 35 to 1 for now. Let's just focus on the 1 to 38, okay? So part A says find the actual odds against a 13. So odds against 13. And we're going to do that here, okay? So if there's only one section of this wheel that has a 13 on it, and out of a total of 38, then the odds of not getting a 13 would be 37 to 1, because there's 37 slots that don't have a 13 and only one slot that does, okay? But here's the deal. Here's what the casino's doing. Instead of doing 37 to 1, they're changing it to make it 35 to 1. Because they still want to make money. So they're going to be like pocketing like that difference of 2, right? And the difference of 2 is actually going to amount to about $10, because 2 times 5 is $10. So they're pocketing $10 every time somebody wins, right? Just because they want to make money. Okay, and we'll talk about that here in a second again. So B, it says how much net profit would you make by betting $5 on the number 13, okay? So they are paying out. This is what this says. The payoff is 35 to 1. So that means 35 people are losing and only one person is winning. So if you are that one person that wins, you win 35 times the $5 bet that you made. Okay, and 35 times the $5 bet is $175 is how much you are going to make, okay? Versus part C says, if the casino was not operating for profit and the payoff odds were changed to match the actual odds, okay, remember that the actual odds is 35 to 1 and not, or excuse me, 37 to 1 and not 35 to 1. If the casino actually changed it to be 35 to 1, okay, how much would you win if the outcome were 13? So if we were doing a 35 to 1 payoff instead of a 37 to 1 payoff instead of a 35 to 1, how much would you win? So in that case, we would take 37 times 5, and that amount is $185. So you should technically be winning $185 if you get the number 13 exactly, whatever, but you're actually only winning $175 because that remaining $10 goes to the casino because they're still wanting to make money, right? So that's kind of how that works. Okay, now I'm going to do one more example, and let's say instead of being 35 to 1, let's say that we have let's do a 30 to 6. Okay, so we still have 36 slots. No. I want to do, I want to do this. I want to do, it would be like 32 to 6, okay? Let's say you have a 32 to 6 chance, right? But the casino's paying out 30 to 6, right? Okay, because they're going to pocket that extra 2 or like really $10, okay? When it changes, when this number is a 6 instead of that number being a 1, there's a little bit of a difference that you have to do when you calculate your amount. Normally, we would just take the 32 times the $5 and call it a day, right? 32 times 5 is whatever that is, $160, right? Except there is 6 of you that are winning typically, right? And not just one person winning. There's not just one person winning here. It's not just you that wins. It's 6 people that win. So 6 people have to share this $160. So we have to divide that 160 by 6. And so each of you are getting like $26.67, okay? So when that number is not just a 1, you have to divide that out because there's 6 of you getting that, okay? Now, this is what you should get, but if the casino is pocketing that extra 2, you would actually only take 30 times 5, which is 150, and you're dividing that by 6, because again, 6 people are winning that. So 150 divided by 6, and that is $25. So you're only going to be winning $25 rather than the $26.67, because they're pocketing that extra amount. Okay, so I do know that on your homework assignment, rather than doing a 1 here, they do another number, and you will have to remember to divide by that number. So that's kind of how that works. Okay, so hopefully that made sense. Refer back to this example when you do that problem, and that should make a little bit more sense. Okay, all right, there we go.